This is All Things Ansys, a podcast from the technical support staff at PADT. Episode 72, a look at Ansys Twin Builder 2020 R2 and news and events from the world of Ansys. Greetings from my elder son's former bedroom on a hot, late September afternoon in Phoenix, Arizona. I'm Eric Miller. I'm one of the owners at PADT, and I'd like to welcome you to our podcast, another episode, number 72 this time. As a little bit of background, if you've ever want to know more about PADT, and we talk a lot about simulation on this podcast, but if you want to know more about the company in general and our history, all that stuff, you can always visit www.padtinc.com and browse our website there. And if you ever want to learn more about me, go to LinkedIn and type in Eric Miller PADT. That's Eric with a C, and you'll find me. You should find me at the top. There's a lot of Eric Millers, but not only one at PADT. And you can learn a little bit more about all the different things that I do besides this podcast. It looks like social distancing is going to be with us for a while, through the end of the year, and maybe through Q1 of 2021. I'm sure it'll change and morph, but odds are we're going to be working from home for a lot longer. So I hope everyone is settled down in their home office, or if you're working from a building, that you're in a safe space. Ansys does have some nice options to make sure you can run remotely, and there's always Ansys Cloud as a solution as well. So if you were waiting, if you're being really stubborn and waiting for this thing thinking this thing's going to end next month, it ain't. So, let your Ansys support provider help you be more efficient. Also, the virus is not the only nasty bit of nature to impact our listeners. The fires in the West and the flooding in the Gulf region have made for some very stressful days. We've got employees in both areas, and fortunately, everyone's safe and everyone's done okay. But especially in the West, the smoke has been really bad, and they've been really suffering from that smoke. So, thoughts out to them, and we hope that no one has been negatively impacted, those of you who are living in those areas. And hopefully, I don't think there was a small earthquake Saturday, but hopefully we're through the worst of 2020. We'll see. So let's go ahead and get started with our interview and discussion. We often talk about the growth of system-level simulation on this podcast, and we're seeing it across a bunch of industries, but especially around the electrification of older products like cars and the Internet of Things as well. So we're just seeing a lot of people being more interested in system-level design. And the dream of creating a virtual copy of your system that you can exercise in real time or really close to real time is really becoming a reality right now. And at the heart of that capability in our Ansys world is a product called Twin Builder. So we thought it would be a good time to revisit this tool with Matt and Josh to get their impressions of the latest release and where the tool stands overall as a way to model systems. I want to welcome everybody to another discussion about what's new in Ansys 2020 R2. Today, we're really going to focus on system-level modeling with the Ansys Twin Builder product. And I've got two people with me, Josh Stout and Matt Sutton. Hey, guys.
Hey, Eric.
Come in.
I hope your Friday's going well. I before we started recording, I shared this, and I'll share it with our listeners right now. I've got about 15 different things going on right now. So if I start talking about PHP code and websites or new learning tools for HR, I apologize because I've got too many things going on. Hopefully next week will be calmer. But what I really like to do is talk about technology. So let's talk about a tool that's been growing since it kind of started life as a system modeling tool on the the Ansoft side, right? And has grown into what we can now call Twin Builder, system level modeling tool. Either of you want to give kind of a high level overview of what Twin Builder is?
Yeah, sure. I can jump in. So I think it's important to just remember that it started life as Simplorer, so it's the same tool that's just been rebranded to a new name, and I think the name is reflective of the direction that it's going, and that it is trying to be a platform for developing and simulating digital twins. So something where you can take a collection of simulations that represent some physical entity and hopefully in real time be able to, or very close to real time, be able to simulate that entity through various techniques so that you can be predictive about how it's going to respond in the real world. So you can control things like maintenance and predict failures, those kinds of things. So that's sort of its direction. At least that's where I think it's headed. I know in the past I've used it just in more of its system simulation level, but that's the direction it's going. And Josh probably knows more about it than I do. So,
oh, not so much. I think the only thing I'd really add on to that is you can kind of think of it as a more general like circuit kind of analysis. We have a whole library of components that are either included with the software you can define on your own. And they're extremely flexible as far as what kinds of physics you want to include. So, it's not just electrical, it could also be fluid related or structural. And we just need to connect them together in a network to get our system representation. So it's extremely powerful.
And those blocks in that network can be an equation, a lookup table, a response surface, or even a physics model from another Ansys product, or maybe a script that you've written in another tool. People familiar with system level modeling and kind of get that, but I think with our audience, I think most of our audience is like me, and our physics guys, or maybe multi-physics people, and we're used to building the big model that answers those one or two physics problems, rather than the system level model. So as we go through this, I think we really want to focus on that audience. If you are a systems modeling person and you speak systems, we're probably going to use the wrong terms, but we really want people who are maybe running Fluent or Ansys or HFSS, Ansys Mechanical or HFSS, to understand, and Maxwell especially, understand how they can use those tools with this product to either model the connection to a controls network, maybe, or other systems to get boundary conditions, as well as providing information to your systems engineers so they can plug in your work into their models, their twins, which is pretty powerful stuff. So, having prefaced with that, let's talk about 2020 R2. My first take on it is a lot of focus on electric vehicles and batteries. What's your guys' thoughts on that?
I would definitely agree with that. As far as the actual list directly related to that, we have just general EV verticalization. So we have some new powertrain libraries associated with EVs. There's also some enhancement to the battery wizard, which is great for basically interpreting test data for battery cells into a simulation environment. Nice. But even on top of that, just all of the enhancements are really support both of these things just from a usability perspective. And in general, the EV space is certainly a popular application for this tool just because of the way it integrates control algorithms and different kinds of physics, as well as the very fast solving reduced order modeling capability.
Yeah, really good point. I mean, an old school internal combustion engine vehicle, the control network of your foot on the pedal, pulling back a lever on the carburetor, we come a long way from that. Very sophisticated, and so we've definitely seen a focus there. Anything really key on the battery side? You mentioned some high-level things, but anything that you think users should be aware of if they're in that kind of space?
As far as new features, I think it's really for the interface of this battery wizard tool. So it used to be extremely sensitive to basically the format of the data that you would feed it. It's now more flexible and it has much better documentation associated with that whole process. So it's much easier to use. Functionally, it's not much different, but it's certainly more accessible to most people.
Yeah, when I looked at just at a very high level, looked at it, it really seems like the kind of tool that would come out of, Ansys is working with a lot of electrification, companies doing electrification. One they talk about a lot, of course, is the VW race car that they worked on that climbed Pikes Peak and set speed records at the Nürburgring Ring. I think this is a classic example of those engineers at all these auto companies, startups as well as established, are like, I need this now, and we're seeing it really get refined as releases go by, due to real world usage. So always been a hallmark of Ansys, and I think definitely if you're using your own tools in the battery space or the electric vehicle space, it's time to take a look at what Ansys is doing, and leverage the fact that they're working with so many different OEMs across the board, and suppliers. Yeah, cool. So that's that area. What other kind of focus did you see in this latest release that people should be aware of outside of the batteries and cars?
I think one area they're always looking to, continually make improvements on is just either ROM creation, ROM validation, ROM visualization. And when we say ROM, obviously just a reduced order model. So something that's a simplification might be too naive, because they're not necessarily simple.
Yeah.
But something that can essentially arrive at a very close approximation to what a more high fidelity model produced in a very quick amount of time. And so that's sort of the name of the game with the ROMs. And so when you generate them, you need to be able to sort of compare to the 3D simulation or wherever it is that they came from. So they've made some improvements on that front, just with visualization tools and validation tools. ROMs are sort of the holy grail of system modeling, so we can get all the fidelity of a 3D physics, but then be able to use it very quickly in some long running, transient type simulation that a system model is going to use.
Yeah, that's kind of a really important thing, is that the system level models need to run fast, right? And you can't do a 5-hour stress or a 15-hour CFD run to get one time point, right? So you got to create these. I always like to think of ROMs as a black box that have an input list and an output list, and you change your inputs, and it'll tell you what the outputs are, and you can plug that into your system and run pretty fast. It seems like a lot of in that area. They put a lot of work into how Modelica, which is kind of an industry standard, models are represented. That seems to be kind of a big thing. If you're, I don't know how many people use Modelica, if it's more of a European thing or an academic thing, but definitely seems a lot of work in that area.
Being a language for describing, almost like a programming language. Well, really, it is a programming language for describing how systems work. Being able to support it, well, just opens up a whole new vista of capability within Twin Builder, because there's so many Modelica models that are out there that you can get a hold of and then use, or you can write your own. So they've made some definite enhancements in just usability, revolving around Modelica. Even simple things like just checking the syntax of some Modelica input that you've created. That could go a long ways to just making your life easier, as opposed to having to try to compile it and realize that it doesn't work, and then much more quickly get feedback in terms of where you may have made a mistake just in entering in the code. Very cool.
Yeah, I would imagine that'd be very useful. Kind of also in the area of ROM improvements is, and this is kind of impressive to me, is the ROM 3D visualization. So you can set up your ROMs so you can actually see what the results are in 3D, rather than, I always thought of a ROM as it gives you 5 numbers, right? So either you want to talk to that ROM 3D visualization enhancements, I guess.
Yeah, so that does depend somewhat on the kind of ROM that you're building.
Right.
So this 3-dimensional view is supported by the static ROM builder. So these are basically snapshots in time, but you do get the full 3D field based on the training data that you provide. So in the past releases, we were limited to just scalar data visualization, so things like temperature fields. But now that we have the 3D visualization for for vectors, we can do things like velocity plots. So it's much more useful for, obviously fluid simulations in this case.
Mm-hmm. Mm-hmm. That's a really good point. So you can, use your control system to open up a valve and then actually visualize how the flow changes without running the full CFD. Yeah, very cool. Anything else on the ROM side before we move on? I want to say something about response. There was a 3-letter acronym that I didn't know that I had to ask you guys what it was.
There are a couple of new ones. The one that's most exciting to me personally as an electronics cooling guy is the LPV ROM, which is the linear parameter varying. So this is particularly exciting for things like active cooling applications. So in the old style ROM, which was basically the most simple approach, which was the LTI, linear time invariant, we were typically limited to just varying heat source values. So we're assuming that the temperature in the domain was linear time invariant is why we use that term. But with the LPV, we can do not only heat source terms, but we can also change the flow field. So if we have an inlet, say a fan condition or something like that, we can scale that up and down and build a ROM based on that as well. So we can do a lot more complicated modeling using this kind of ROM than we could with the old system.
Let's dig a little bit deeper into that for people that are maybe providing these. What's the workflow if I'm a Fluent user and my systems guy says I need a ROM so I can play with the fan? What does that look like?
So we need to generate a set of training data is the first step. So we need to, say, parameterize our fluid simulation. So we'll have, say, an input for each heat source, and then we'll have an input parameter for the flow condition at the inlet. And we'll need to run a series of dynamic simulations so that we can see how the system evolves as we apply each of these inputs as usually a step condition. So as long as we have, say, one simulation for each of these training points, we can build a ROM based on that kind of conglomerate of information. Okay.
And they have a tool that helps you get the results from those Fluent runs into that ROM, correct?
I believe that's something they're always improving. I think there is a defined workflow for the LTI portion. I'm not sure if that has been implemented for LPV yet.
Because it's new. Yeah. Okay. Cool. That's very exciting, actually. I think there's a lot of capabilities there that people would want to include in their models. What else? It seems like your normal set of enhancements to the user interface and stuff like that. Anything stick out with you guys on those changes? UI side.
Yeah, I think I think they're always making improvements in that area. Nothing drastic, I don't think, has been changed in this release. I mean, it's been several releases now that they went to the ribbon interface. So that was a pretty dramatic change, but they're sort of stabilizing on that. I know they're making some. It's not a UI level enhancement, but they are trying to expand the scope of being able to run these cross-platforms, so being able to run some of these systems on Linux as well.
Okay.
And so you can typically, most users, probably 80-90% or more are running on Windows, but there is the ability to export a Twin, and then there's a Linux runtime that exists now, so that the Twin can actually be run on the Linux platform. And that's useful for, if you're doing high performance computing, a lot of times that's going to be in the Linux environment. So running these under that condition requires Linux. And so that's one of the improvements that they're making as well.
Good. Yeah, that's it takes time to do these things, right? Never have enough developers and enough time. So yeah, it just seems like that was kind of my impression as well, is just probably user requested enhancements, and that can be really useful to help you just be more efficient in your workflow. I think that's pretty much it, right? I mean, there's a lot under the hood to those enhancements, especially on the battery side, battery modeling side, electric vehicle modeling side. But just being, unless you're in that space, you have to dig into them. Anything else you guys want to share before we wrap it up?
Oh, I particularly had to provide input on.
Yeah, I'm sort of the same way. I think it's just it's worth trying out, though. If you
Yes.
if you're just trying to model some simple system, you can even go back to your simple circuits basics and start there, and then because that's sort of the paradigm for the whole thing. And so once you get that under your belt, then moving on to some of the more system level twin building type endeavors is possible.
All right. And of course, all this is on the Learning Hub. For those of you who have access to the Ansys Learning Hub, there's a lot of good information there, and in the documentation of the manuals. It's really coming along a long way. And as we all know, system level modeling is the next territory to conquer in the world of simulation. I think the simulation people would tell you, the systems people will tell you that they've been doing it for 30, 40 years. But I think incorporating all the physics accurately into those system models is what we're really talking about here. And we talk about hardware in the loop and software in the loop, and now we're being able to say simulation in the loop for modeling your systems. And I'm pretty excited about it. Our customers seem to be embracing it as well. So I think that's pretty much it. I really appreciate your guys' time. I appreciate Josh's gardeners not cleaning outside his window like they were in the last podcast we talked on. So it's always risky on a Friday afternoon. It seems like that's when leaf blowers are running Phoenix. Do you have leaf blowers in Arkansas, Matt?
I do, and I also have a dog, but fortunately, she's asleep on the couch right now. So.
And your kids are not complaining.
No, well, not loudly. So,
my son was taking a French test when our internet went down about an hour ago. I feel for anybody with younger kids.
Did he curse in French, or was it?
That's exactly was my thought is, why are you taking French if you can't swear in French? So I think he just doesn't do it in front of me. So
yeah, there you go.
Well, I really appreciate your time as always. I learned some stuff, and I look forward to future releases of this tool as it becomes more and more capable and enhanced. Highly encourage our listeners, even if you don't do system level modeling, learn more about what this thing can do, because the rest of your company can benefit from you providing input into system level models. It's very powerful capability there. You guys have a great weekend. We'll hopefully talk to you guys soon. Thanks a lot.
Great. Thanks, Eric.
Bye.
So hopefully that was a good overview for all of you to get a little bit of a taste of what's there. There's a lot going on, and there's much for all of us to learn. As I stated, we're approaching this tool as a physics, from the point of view of physics and multi-physics simulation people, and trying to understand how we, for our own consulting at PADT, as well as for the customers we support for Ansys, can use this tool and leverage this really powerful technology. And we're seeing some great things. It's really, really cool. Maybe it's time for you to have a discussion with your systems and or your controls group and see how you can better support them and how Twin Builder can fit into whatever tools they're using to do system level simulation. So definitely have that conversation. We're seeing more and more people do it, and it's going well. It's a lot of value there. So it's time to pay the bills, even though there really are no bills. And I think we would do this podcast even if it didn't bring in any business. But since we've got your attention, we might as well say some words, and it wouldn't hurt for you to send some business our way. So have you considered PADT as your trusted partner for simulation consulting? Have you ever sat in a meeting and looked at the schedule and thought, there is no way we are going to get this simulation done in the time needed with the number of engineers we have? There's just no way it's going to happen. Or even the thought of, I could bring someone else in from the outside, but it would be almost as much work to explain it to them and get them up and running and take just as much time as kind of figuring out a way to do it in-house. Well, when that feeling of panic starts growing, push it back down and reach out to PADT. We're easy to work with from an administrative perspective. Nobody wants to throw stuff over the wall, but we catch well. If you need to throw a job over the wall, we're here to catch. We know what we're doing, and we speak your language. We do project management. It's built into each of our projects, so you don't have to do that as well. And we have the experience across the entire range of Ansys products. And not to mention that our industry-specific experience is getting so broad that it's really starting to become a bit surreal. From ocean-going vessels to MEMS devices, from toddlers' toys to massive solar arrays, we're here to help. So shoot us an email at info@padtinc.com, and let's see how we can help you get your projects done on time. All right, that out of the way, let's take a look at the Ansys stock. It's Sunday when I'm recording this. So on Friday, August 18th, it finished at 305.08. So that's tech stocks in general took a downturn, and Ansys did as well. Having peaked at the start of September at over $350 a share, it's back to where it was in early August, which is still not bad. In fact, it's up 18.2% year to date, which is pretty impressive considering all the stuff that's been going on these days. So the stock's doing well. I think we'll continue to watch it and see how it does as we get to the end of this quarter. And of course, the all important, from a Wall Street standpoint, Q4. There's really no new Ansys news that they've released, and we haven't released any news at PADT. So let's talk about blogs. I think I was right. I kind of guessed that maybe people are doing something else and not working on blogs because there weren't a lot of new articles published. And then all of a sudden, boom, there were a whole bunch of new ones. So I picked 3 as usual, but there's a whole bunch more. So check out the Ansys blog on the Ansys website. The first post I saw got me really excited because it showed a roots blower. It's a kind of compressor, and it's something that PADT used to specialize in designing custom roots blowers for people, especially for hydrogen. This article was about how to improve compressor efficiency with design optimization. And it's got some great high-level information about compressor simulation. Then it talks about how to use the Ansys Forte tool to model this kind of thing. So Ansys Forte is part of the suite of tools that are generally used to model internal combustion engines. And it's great moving mesh, objects moving within a fluid type of a modeling tool, which you need for an internal combustion engine, but it's also applicable to a lot of other things that squish or expand gases and fluids. And we don't really, in fact, it inspired me to maybe get somebody from the Chemkin Forte group to come on and talk about it. We usually use it here at PADT for combustion, but it was kind of an eye-opener to see that we could be using it to do some great simulations on some of the compressors we design here, some of the positive displacement compressors we design here at PADT. So check it out. It's got some neat simulations of spinny stuff pushing gases. Really, really neat. Also, if you remember a couple of months ago, we mentioned that Ansys was going to be the simulation sponsor for an electric airplane racing series. Well, the first article that came out of that partnership is on the blog. It's super cool. So it's called Ready to Take Off: Simulation Charges Electric Air Racing. And I'm really excited to see how this series progresses, the racing series, as well as the application of Ansys to those aircraft. And last on my list, my third article was about vertical farming. So kind of unusual for Ansys, but if you remember, Ansys has some really cool tools for fluid flow, as well as lighting simulation. And lighting turns out to be very important when you're growing plants indoors in a vertical farm. So the article talks about, just kind of from a general standpoint, the coolness and the power of growing produce at the store, basically, or maybe at your apartment building. We're seeing more and more of that as cities are becoming more crowded. So instead of spending that fuel to ship it, why not grow it where you're going to buy it? And then they talk about, of course, how simulation can be used to get a better yield, and lighting being the critical portion of that. They even make an illumination pun, as you would hope, in the article. So do check that out. It's called Vertical Farming is Coming to a Store Near You. And I think it is, and Ansys will be a part of it, which is really cool. That brings us to upcoming events. PADT webinars. We have one webinar scheduled for October so far. It's on LS Dyna 2020 R2, Ansys LS Dyna 2020 R2 on October 7th. As usual, that will be at 11 a.m. Phoenix time, which is 11 a.m. Pacific as well. So go to Bright Talk and search for PADT Dyna, or go to www.padtinc.com/events to learn more and to register. And speaking of that website, padtinc.com/events, We've got a lot of other non-Ansys related stuff in September. I actually got 3 more events before the end of the month. So on the 23rd, 2 of them really deal with STEM and inclusion, or tech and inclusion. The first is PADT is sponsoring the Tech Inclusion Forum, which is part of the Arizona Technology Council series on that topic. And the first one is going to be on historical context and call to action in understanding racism. So we're going to start with a discussion, get all of our specifications in place, being good engineers, and understand where we're coming from before we tackle the problem of systematic racism. So it's a great discussion. The panelists are fantastic. I've been working with them for a while. I'm really looking forward to that one. You don't have to be in Arizona to attend. And that's, again, going to be on the 23rd. Then on the 24th, there's going to be something called STEM Education Workplace Equity Forum. And this is with a group out of Colorado that PADT works with, and we are also a sponsor of this event. And it's really focused on the food chain, feeding that funnel, right? The food chain of if we want more inclusion in engineering, we need more inclusion in STEM education. And this is a panel with some people that have actually made it work and gotten inclusion at the STEM level as well as at business level. And they're going to talk about what works and what doesn't work. And it's a great discussion, great panel. And a lot of who's in tech in Colorado are going to be there. So we're proud to be a sponsor of that. And lastly, speaking of Colorado, which I really miss visiting, by the way, those of you listening from Colorado, it's been way too long. I hope to get back soon. But anyway, the third event for September is the Colorado Life Sciences Innovation Forum and Trade Show. Day 1 is on September 30th, and day 2 is on October 1st. We will have a virtual booth. So if you are attending that event, please stop by our booth. It's really cool, and we'd love to talk to you, and we can't wait to hear from all the different companies that are presenting at that event. It's always a great event live, and looking at the agenda, the virtual one's going to be really cool, and it's easy to attend. You don't have to be in Colorado. So if you want to go to any of those, all you got to do is go to www.padtinc.com/about/events.html. That's the full thing, or you can just do /events. That's much faster. And you can see quick update on October. Of course, we've got that Colorado Life Sciences Day 2, and then the Tucson Tech and Business Expo is on the 7th of October. And also on the 7th is that seminar on Ansys Hellas Dyna. And then we're finishing up the month. Actually, it's the middle of the month. It's not finishing up with the CEO retreat, the Arizona Tech Council CEO retreat, which is we're going to be doing virtual as well. So we're looking forward to that event and hope to see some of you there. So that's it for all the events for this month and next. And that brings us to the end of the podcast. So I want to thank all of you for listening. Don't forget to subscribe to our emails at www.padtinc.com/opt-in and spread the word about the podcast. Subscribe to the podcast if you haven't already, and let other people know about it. Don't hesitate to reach out, and we want to thank you for your time and for listening. Thanks. Thank you for joining us for the All Things Ansys podcast, episode number 72. As a reminder, this podcast is not affiliated in any way with Ansys Inc., and the opinions expressed are those of the people on the show only and not of their current or former employers. For more information, please visit www.padtinc.com/blog, and please share your thoughts and questions through an email to podcast@padtinc.com. See you next time.